Class. Today we are going to discuss the questions of Digiquest, which was given in Digiquest of 8th October, and now we are going to discuss the questions of chemistry. And the first question was question number 91. The first question was question number 91, and in question number 21 it was said the dissociation constant of water at 25 degrees Celsius. The dissociation constant of water at 25 degrees Celsius we have to calculate. The temperature was given 25 degrees Celsius and we have to calculate the dissociation constant of water. So, we know that water undergoes self ionization or auto ionization to form a molecule of hydronium ion and a molecule of OH minus ion. This is the dissociation or self ionization of water. This is the auto ionization or self ionization of water, where two molecules of H2O undergo dissociation to form a hydronium ion and hydroxyl ion. Now, we have to calculate the dissociation constant of water. If we write K is equal to concentration of hydronium ion, concentration of OH minus ion and upon concentration of H2O raised to the power 2, because we have a stoichiometric coefficient 2 over here. So, it would be having a power of 2, and when we are multiplying this with K H2O whole square, concentration of hydronium ion and concentration of hydroxyl ion. So, this factor is known as Kw, that is ionic product of water, and will be equal to concentration of hydronium ion and concentration of hydroxyl ion, and it is asked at 25 degrees Celsius. So, the value of Kw at 25 degrees Celsius is 1.0 into 10 to the power minus 14, and rather to be more sure, it is moles square per liter square, that is the value. The next question is question number 92. In question number 92, it is asked the pKa of a base, and Kb is given as 1 into 10 to the power minus 5. So, if the value of Ka is given, we can apply the formula. The formula is POH is equal to pKb plus log 10 salt upon base. This is the Henderson's equation, and we can apply this one, concentration of salt upon concentration of base. This is the Henderson equation. We are given the value of Kb, and further we can apply one more formula not related to this topic. So, we are given about the value of Kb, we can calculate the value of POH, and we can neglect this portion. So, pKb or Kb is given. So, pKb is equal to minus log 10 Kb, and on further solving this the value of Kb. So, further on solving the value of Kb, the value is found to be, when we will calculate the value of pKa, it will be equal to 9. It will be equal to 9. Now, next is question number 93. Question number 93. What molar concentration of NH3 provides OH minus concentration of 1.5 when Kb is given as this much? Okay. When NH3 is dissolved in water, it forms ammonium ion plus hydroxyl ion. This is the dissociation, or we can say in this way it is dissociated. Or we can further write this expression as NH3. This should not be the way to write the function. It may be further written as NH3 is dissociated as H plus ion and NH2 minus ion. This is the value, and further we can apply the formula pH is equal to pKa plus log 10 salt upon acid. We can further apply this formula, and on further applying this formula, the question was asked that the value of pKa was given. the value of Kb was given, for the base it was given, and the concentration of hydroxyl ion was given, and further we have to calculate the molar concentration of NH3. We have to calculate the concentration of NH3. So, Kb was given and concentration of OH minus was given. So, we can calculate from OH. Further, POH is equal to PKb plus log 10 concentration of salt upon concentration of base. You can solve from here, and further on taking the value of Kb, OH is given. The value of POH can be calculated as minus log 10 concentration of OH minus ion. So, we are given with the value of, from here we can calculate the POH minus log 10, and concentration of OH minus ion is given as 1.5 into 10 raised power minus 3, it is given. So, on solving this one would be equal to 3 into log 10 1.5, this would be the value. So, finally, when we will calculate the concentration of NH3, it would be equal to 0.125 plus 1.5 into 10 raised power minus 3, it would be equal to this one. This is the final answer. Question number 94. At 90 degrees Celsius, pure water has a concentration of this much. The concentration of hydronium ion is given to be 10 raised power minus 6. And the concentration of OH minus ion would be equal to 10 raised power minus 8. So, the value of Kw would be equal to 10 raised power minus 14. This would be the value. Next is question number 95. The pH of pure solution containing 0.1 normal HCl is given. It will be dissociated as H plus ion and chloride ion, and the second one is acetic acid. Acetate ion and H plus ion, it would be dissociated as like this. So, we have a 0.1 normal solution of HCl and 0.1 normal solution of acetic acid. So, the pH will be calculated as concentration of both the ions. So, if this is 0.1 normal, this would be equal to 0.1, and this would be equal to 0.1, and this would be equal to 0.1 normal, or the pH of the solution would be equal to 1. Next is question number 96. pH of 10 raised power minus 11 molar HCl. If we have HCl solution, it will be dissociated as H plus and Cl minus ion. So, the pH is equal to minus log 10 concentration of H plus ion. We have concentration of H plus ion as 10 raised power minus 11. So, it would be equal to 11 into 10 raised power 10, or it would be equal to 11. This would be the value of 96.1. pH of NaCl solution. We have a NaCl solution, it would be dissociated as Na plus ion and Cl minus ion, and also it would be having a saturated solution, whatever will be dissociated as H plus ion and OH minus ion. So, the pH of 10 raised power minus 3 molar HCl, we have 10 raised power minus 3 molar HCl. So, it would be equal to 10 raised power minus 3, it would be equal to 10 raised power minus 3. So, if we have a 10 raised power minus 3 solution NaCl, So, the pH would be equal to minus log 10 concentration of H plus ion, it would be equal to minus log 10 concentration of 10 raised to minus 3, or it would be equal to 3, and provided we have a NaCl solution, then the pH would be equal to 10 raised 14 minus 3, or it would be equal to 11. It would be equal to 11. Next is question number 98. The diffusion constant of acid HA is this much. This is the diffusion constant. The value of K is given as Ka 1 into 10 raised to power 1 into 10 raised to power minus 5, it is given. The pH of 0.1 molar solution. It is given as like this, and if we have a pH of 0.1 molar solution, we have 0.1 molar solution, 0.1 molar, 0.1 molar. The value of K is given as 1 into 10 raised to power minus 5, concentration of H plus ion, concentration of A minus ion upon concentration of HA. This could be solved, and on solving this one, we will have the pH is equal to minus log 10 concentration of H plus ion finally. Next is question number 99. Which of the following would decrease pH of this much? We have 0.01 molar HCl solution and volume is given as 25 centimeter cube. So, we have HCl solution and we have to decrease the pH. Further decreasing the pH, we have to add 25 centimeter cube of 0.02 molar HCl, then it would be decreased. Now, question number 100. We have NH3 solution, and when we will dissociate this NH3 solution, we have H plus ion and NH2 minus ion. So, we have 0.01 molar, 0.1 molar. So, the value of Kb is given as 10 raised to power minus 5, and we have to calculate the pH. Okay. So, when we have this 0.1 molar, then it would be 0, it would be 0, and when we will have X, this would be X. So, Kb is equal to concentration of H plus ion, concentration of NH2 minus ion upon concentration of NH3. The value of Kb is given as 1.8 into 10 raised to power minus 5. Concentration of H plus ion is given as X square upon 0.1 minus X. This is a quadratic equation, and on solving we will get the value of X from here. X will be equal to 10 raised to power, it would be equal to 0.1 minus X, and it would be equal to 0.1 minus X multiplied by 1.8 into 10 raised to power minus 5 is equal to X square, From here we will get the x value of x, from here we will get the value of x, and it will come approximately what we say, and after that we have to calculate pH. So, pH will be equal to minus log 10 to the concentration of H plus ion, and we know that the value of x can be here, that will be the pH. Now, next question is question number question number 101. In a buffer solution of a weak acid and its salt, if the ratio of concentration of salt to the acid is increased 10 times. So, in a buffer solution, the ratio of concentration of salt to that of acid. So, we know that pH is equal to pKa plus log 10 concentration of salt upon concentration of acid. This is the Henderson's equation, salt upon acid. So, it is said if the ratio of concentration of salt to that of acid is increased 10 times. So, let it be the equation number 1, and if it is increased 10 times, then it will be 10 to the concentration of acid, and this will be equal to the concentration of acid. Concentration of acid must be cancelled. pH is equal to pKa plus log 10, pH is equal to pKa plus 1, that means it increases by 1, it increases by 1. The process of hydrolysis can be either exothermic also, or it can be endothermic also, it can be anything, both. Question number 103. The solubility of barium sulfate in water is this much. Barium sulfate is given. It can be dissociated into barium ion and sulfate ion. It can be dissociated into two. The solubility is given as 0.1 molar. The solubility is given as 0.00233 grams per liter at 30 degrees Celsius, and we have to tell it at 0.1 molar ammonium sulfate. Further, if we have ammonium sulfate, so it can be dissociated into ammonium ion and sulfate ion. So, we have a common ion effect over here, we can say that. We have a common ion effect over here. So, and it is given it is at 0.1 molar. So, this would be equal to 0.1 molar, it should be equal to 0.1 molar. So, we have we have a common ion effect over here, it will be dissociated and it will be suppressed. Next is question number 104. Which of the following statements about buffer solution product is weak? Weak acids and their salts are better as buffer for pH less than 7. Weak bases and their salts are better as buffers for pH is less than 7. A buffer solution has generally lost its usefulness when one component of buffer pair is less than in the acid range or basic range, the two components of the buffer should have almost the same mass. A better buffer solution has generally lost its usefulness when one component of buffer pair is less than about 10% of the other. Okay. So, weak acids and their salts are better as buffer for less than 7. We know that if we have weak acid and its salt, that means it is a acidic buffer, and we know that if it is an acidic buffer, its pH would be less than 7. So, the option would be weak acids and their salts, weak acids and their salts are better as buffers for pH less than 7, for pH less than 7. Next is question number 105. In which of the following aqueous solutions is the degree of dissolution of water maximum? It would be sodium acetate. Question number 106. The equilibrium constant for acetate ion is given pKb 4.69 and pH is given as 9.25. So, okay, we know that pH is equal to pKa plus log 10 concentration of salt upon concentration of base. And on solving, we will get these values. As we are given the value of pH, we can calculate the value of salt. And the value of K is concentration of cyanide ion, concentration of acetic acid, concentration of HCN, concentration of acetate ion upon concentration of cyanide ion, concentration of acetic acid. Next is question number 107. Solubility product of A2X3.4H2O it would be equal to A 3 plus square x 2 minus whole cube H2O raised to the power 4. Question number 108. A 0.04 molar solution of CH3 and NH2 is diluted to reduce its molar concentration to half. The change in pH during dilution is okay. This would be the dissolution. They have 0.04 molar this one, and pKb is given as 3.3010. This would be the value, and we have to reduce its molar concentration to half, means we have to make the concentration 0.02 molar. We have to dilute and we have to calculate the change in pH. Okay. when we have to calculate the change in pH, POH is equal to pKb plus log 10 concentration of salt upon concentration of base. This is the value. This can be solved like this, and the value of OH can be found. It will be equal to minus log 10 concentration of 3.3010 and log 10 salt upon base. This is given as log 10 0.04 molar. It can be calculated out. So, from here we can calculate the value of POH, like 3 minus log 10 concentration of this was 3 0.1615. Thank you, class.